right, last talk in this session. We welcome Guido Trotter, who's working at Google, apparently, and he's speaking about Debian enabling the developer use case on Chrome OS.
Hi, how are you? My name is Guido. I work at Google. I'm also a long-time Debian developer. I came to present some way in which Debian is used on the Chrome operating system, and hopefully it will be also Debian relevant in various ways, and we'll see. So let's start a bit from what is Chrome OS, right? Chrome OS is a Linux-based operating system that mostly runs Chrome. It is not probably the operating system most people in this audience would use, but hopefully we will discuss things that can be applied to Debian as well as like Debian-related things in Chrome OS. Chrome OS is also a very readily available operating system, right? And it is a bit easier to get than Debian, like you can just go in a shop and buy it, which helps for some audiences. And the fact that now you can run a full Debian system on Chrome OS is, in my opinion, a good news and another great way that more people can access to Debian that couldn't before. So let's see how it is. What we're going to do today is, first of all, just go a bit into how it works and how it looks like on Chrome OS, because most people here probably wouldn't have seen that. Then we go into a bit of architectural talk about how it is implemented, what security measures we took, and maybe some of these things can be applied outside and have actually been applied outside. So that might be interesting outside of the Chrome OS world. And finally, we're going to do some advanced usage over what other things you can get done in this type of system that is not exactly the normal use case, and maybe we'll try a demo, maybe. Or if that fails, I have slides. Cool. So getting started, once you're on Chrome OS, which, as I said, normally runs just Chrome and Android apps, but you can just go either in the settings and like enable Linux beta or look for the terminal, click it, right? And then you just get an installer, right? That just sets up Linux progress bar terminal, right? So this is just Debian getting installed, and then you have a Debian system on your Chrome OS device, and you can use it like your normal Debian. You can apt-install things. Once you have apt-installed them, the icons for at least the non-terminal programs, so everything that has a GUI and has a .desktop, will appear inside the Chrome OS menu. And this is an example with Eclipse and NetBeans and so on. One thing I should mention is the reason and the rationale for this feature is to enable developers to use Chrome OS, right? So Chrome OS is used by companies and other places, and we want to allow people that, for example, do web development or Android development or other type of development to use Chrome OS. It can be used for any app, really, but we gear it at the developer experience, right? So after you have your icons, you can just start your compiler GUI ID, and that just works, right? Of course, it's a full Debian system. You can do anything. You can do almost anything you can do with Debian on it, and we'll see what the limitations are and why. Other things that we have natively, you can share Drive. So anything like Chrome OS accesses natively Google Drive, and you can share a folder with Linux, right? And then it's mounted in your file system, and then you can save things inside with like either from Chrome, you can save it and then access it from Linux, or vice versa, right? And this applies both to Drive and your local file system, of course. And we have networking, right? So if you develop something related to web, right, you can totally connect from Chrome to your container and test how it works and set it up and so on. This is just the Debian standard Apache running on it. Reachability via the network is there is this host name, Penguin Linux Test, which you can reach it on. We will do dynamic port forwarding from local hosts. What happens now is that if some application on the terminal shows a URL and you click it, it opens it in Chrome. But if it's localhost something, that might confuse Chrome unless it's a known port that gets forwarded automatically from to Crostini, which is like the code name for Linux on Chrome OS. What will happen after is that as soon as you open a port on the Linux side, it will be automatically forwarded to localhost on the other side. And we're also working on enabling port forwarding completely so that on your Chrome OS you can export the port externally. I don't recommend using this as a server. It's more really for the test case. And finally, in settings, like you can manage your shared files and folders, unshare something that you shared before. There are USB devices that you can share with the Chrome OS so that if you plug something, then Linux can see it. And you can just delete everything and start from scratch. If you break it, you get a new one very easily. So things that work, we recently released the USB pass-through. It doesn't work as a general case, but we're working on a general case. But right now, at least like Android devices and a few other devices, you can just pass through to Linux. Automatic localhost port forwarding is something that we're working on as well. Audio support now works. Fuse now works, it didn't used to, and we'll see why this limitation is there, right? Finally, another thing that we worked on is manageability features. So Chrome OS has an enterprise world where you buy a fleet of these, you give them to 100 developers, 1,000 developers, right? And then you manage them centrally with policies. And then we have policies to control whether the device is allowed to use Linux or not, and if it is allowed, whether the single user is allowed or not, or whether the user who is a guest user, like not a user of your organization, but just like someone logging in with their Gmail account, can use Linux or not, if it is an enterprise device. If you buy a consumer device, you can just use it, and it's yours, of course. So things that we're working on and are you can already use in some cases, but are not completely polished and finished, are GPU integration, which is useful, even like a lot of tools for developing, like have menus that might be slow otherwise, and if you want, you can play some games on it. Like you can do basically anything related to GPU. Full USB support for any sort of device. A managed upgrade to Buster. I mean, Buster was just released. It used to install Buster -1. What was the name of Buster -1? No, I forgot. Anyway, old stable, or like previous stable, right? And finally, the full port forwarding from outside is also something we're doing. So the managed upgrade to Buster basically is just going to look like you don't have to get in the container and know what to do apt and so on. You'll just get a screen saying, hey, do you want to upgrade to Buster? It's time. And you click and hopefully everything works. We'll see. So let's go a bit into how this is implemented and the insides. Because the previous part was just like a bunch of screenshots, right? So maybe a bit boring, but hopefully this part is a bit more interesting. So it's a bit of a Matryoshka style. We'll see that we run like VMs inside containers, inside VMs, inside containers, and we'll also see why. The general architecture is this one, right? So we have the normal Linux operating system, which is Chrome OS, right? It runs Chrome, and it runs this virtual machine manager, which is based on KVM, but replaces Linux with something called CrossVM, and we'll go into that. On top of that, we have a guest VM called Termina, where, of course, a guest kernel is run, and via LXD, we run Debian inside an unprivileged container. This is basically like full sandboxing, and we'll see that CrossVM is actually implemented with other containers under it. So it's really containers here, CrossVM, Linux, LXD, and a container on top of it. And this is done basically to guarantee that whatever happens inside the Debian system, it will not affect Chrome and the Linux outside, so that you keep the security guarantees of Chrome OS intact, even if you install something inside Debian that might be compromised. We don't know exactly what happens there, but we know that your Chrome shouldn't be reached by there. So let's go a bit inside CrossVM, right? It's basically a replacement of QEMU that is written in Rust so that we have memory safety, and the various device drivers that they have run inside a software called minijail, which is basically a container with syscall filtering and access filtering and so on. Still, like, only Linux on Linux, right? And it was created originally just for Chrome OS, but Amazon started using it on their cloud, interestingly enough. And now we have this common code base that we started at Rust VMM, which is basically like cross VM, but the generic parts that are shared between the two of us, right? And if more people want to use it inside Debian to run this kind of architecture for other purposes, they're welcome to use the code. It's all open source, of course, right? So it's all free software. Feel free to use it, contribute it, package it for Debian, anything, right? So let's see a bit more how this works, right? So we have this cross-VM process, and cross-VM process forks a single process for each device it has to access, and all these processes are jailed singularly to a container that can only access that single device. So, for example, the root file system, right, is exported through a file to a container that sees only that, and there's a process that implements that device and gets accessed by the general cross VM. So it should be a tiny bit more insulated and secure than QEMU, according to our security people. You can, of course, double check it and verify the security characteristics and see if it works for you. And of course, it's then a standard like KVM operating system. So there's a guest kernel, right, that calls into cross VM to access various devices, right? So very simple, very standard KVM, except that QEMU was replaced by cross VM. Other things that we did, so on the host, so inside Chrome OS, we use Chrome to generally just draw windows, right? So it's your window manager on the Chrome side. Of course, you don't run like X inside a window. We wanted everything to work very transparently as part of the same operating system, right? Then we have a way to manage the life cycle of these VMs that we called concierge. And then we have a way to manage the containers that run into these VMs. So what we saw here, right, is that we have VM privileged containers. In reality, you can have as many of these as you want and as many VMs as you want, and we manage the life cycle of both. And then finally, we export file system via 9p, via another daemon that does that. No, I'm still here. Okay, interesting. Cool. Then let's go into this Linux VM. We call it Termina. It's basically another Chrome OS, very slimmed down and stripped of pretty much anything. Runs Linux 4.19, and it is completely read-only. So even if you get root in Termina, like actually you cannot get root in Termina, you get like an unprivileged user there that can control LXD and a few things. And Termina is a complete read-only file system that cannot be changed and is just used to run a file that is read-write that then contains the file system of your VM. So there are some daemons basically that are controlled by gRPC. So from Chrome OS, you talk to Termina to do things to LXD. You can use LXD directly, and we'll see that. But in the normal case, when you click through the menus to do things, Chrome OS talks to these daemons inside Termina that start the containers that work inside. In Debian, we had also a couple of changes, but it's literally just like two extra pieces of software, right? One is this Wayland compositor that will draw windows, passing them on to the Chrome OS side. And then we have a guest agent that is helpful for us to call into it. And for example, it can install a deb. so that if you download a Debian Chrome OS and double click on it, it will just send it to Crostini and install it, and all these kind of things, right? And this is what is going to be used, for example, for the upgrade, right? So Chrome OS will call into Garçon that will say, oh, upgrade time, I'll upgrade to Buster, I'm done. And this is very similar to what you see basically in cloud, right? So when you install Cloud Init and all this kind of stuff, right, then the cloud can control things inside the container. Same things here. Chrome OS can control things inside the Debian system. And that's pretty much it from how it works architecturally, right? Now what we can do is try a small advanced usage type of thing in which we see a bit like, for example, how to run multiple containers and how to interact with the system in a way that is not the boring, like, click through and so on. So let's see if it works. Otherwise, there are slides. So what I can do is, I'm inside Chrome now. So if I just type Ctrl-Alt-T, I access the Chrome shell. Can you see enough? Or should I increase this font? Okay. How about now? A bit more? No, that's okay. Okay, cool. So things we can do is just call, for example, VMC, right? And this just shows you like that we have one VM called Termina, and these are the things that we can do to it. VSH allows us to just connect to it. So if I do VSH Termina now, it either works or doesn't work. It doesn't work because it was not started. So I can do VMC start. I can enable GPU. I think it's enabled by default at this point in this version, but I'm not sure. No. So I started now. Should be relatively fast. Done. I'm already inside. But if it was already started, I can do VSH Termina. And I'm inside it, right? At this point, I'm just inside a Linux system. I can type LXC, right, and do most things that I can actually get done here. So LXC list shows me what kind of machines I have. I was playing with it a bit. Normally, you would see just Penguin. Penguin is the name of a Debian container. But at this point, I was already playing with it, so you see that I have another couple of machines that are all stopped. So I could do LXC start Penguin, but at the moment it stopped. If I just click on the terminal, it will start itself, so there's no point. Let's see it. Here, I'm inside, and here, now it's running, right? But if I want to start some other one, I can just do LXC start or LXC launch and an image, right? And you have a pretty much complete LXC installation, right? So you can see these are the remote lists. These are the ones that are there by default. There's the local one, pretty empty. And there's images that just is like anything that is on linuxcontainers.org. So that's where I got my images from, right? So let's try list images Debian AMD 64, if I remember the syntax. Nope. Image list. So here I will see all the AMD 64 Debians, right? Like a few of them. And then I can easily go LXC image copy images Debian 10 to local. And then it should be super fast because I copied it before, because otherwise we would stare at it downloading it for a while. Hopefully. Fingers crossed. No, come on. Yeah, copied successfully because it was already copied before. Yeah, I mean, it worked but you know, otherwise we stare at the downloader. Cool. So once we have them, right? We have it here in local, right? And then I can launch a completely new one, right? So if I do LXC launch Debian 10 Buster 2, I didn't have a Buster 2 before, I swear. It's creating it, starting, done. And at this point I can do LXC exec Buster 2 bash. I'm root inside it. And at this point I have a Debian Buster inside it. Again, the standard penguin is Buster -1. What was Buster -1? Stretch. Thank you, thank you. It's been like, it's just the standard one, like stable. Cool. So let's just try, I'll install OpenSSH server. Why not? Because I don't want to keep, of course, accessing it via an exec call inside. Really? It was just OpenSSH server. Come on, do it, please. But I mean, already here, in the meantime, while it installs, I should be able to access already Buster 2, right? And then if it installs, I should be able to SSH it after I configured it very improperly. Okay, it's done. So let's change the password for root to something unsecure. It's not scolding me, interesting. The other distribution I was using was scolding me. Last time I did this demo, I did it with another one because Buster was not out, so there was not much point in installing another Debian since Debian is the one that it gives you by default. But now, since we can play with Buster, of course, we should just, like, on camera do all the things that we shouldn't be doing. Yes. I'm sure they should have used some systemd command to do this. Sorry. No, of course I'll trust anything. Yeah. What? Cool. So now I can access it from my normal container, and this is my normal container where I can install all the applications and have them show in Chrome OS. Other ones you can do, like, I guess mostly useful for non-graphical stuff. If you want to run graphic apps, the best place is really the standard container that we give you, that then is fully integrated and so on. In theory, you can swap them around as well. So if you rename Penguin to something else, then you can rename Buster0 to Penguin, and then it will act as the standard container. You should probably, if you do that, try to make sure that all the various daemons are installed inside it so that it can communicate with it, it can get your apps from that container and so on. And I think that's pretty much it. That's what I wanted to cover. Thank you. Do you have questions?
Any questions?
Ask me something that I cannot answer.
Oh. IPv6 support for the guests?
IPv6 support? I think so, yeah. I mean, it's 2019, right?
Thank you.
We can check. I'm pretty sure, yeah. Yeah, see. I think so. I know this is. Yeah, yeah, yeah. I don't know. I mean, maybe it's just knotted. And, I'm not entirely sure. Should be, hopefully. Anybody else?
I'm just wondering how deep did you went, because you have Chrome OS, then you have this terminal, then you run something, and then you run this LXC. So I got lost in this inception.
Okay. I can go through it again, right? So inside Chrome OS, we run basically one KVM instance, right? That runs one virtual machine. Inside that one, we run an unprivileged container. That is what you can access and read, write, install applications, and so on. I went a bit more in details about how this hypervisor layer is implemented, but you don't need to care about it too much unless you're interested in the hypervisor layer per se. So it is basically an unprivileged container that instead of running directly on Chrome OS, it runs inside a virtual machine, right? That's how deep we went. Then the security layer of the virtual machines includes other containers for each device driver, but you don't need to see that or care about it. Is that clearer? Yes, cool. Any more questions? No.
All right. Thank you very much.
Thank you very much. It was a pleasure to be here. This is my favorite conference. I'll see you again next year. And around, of course. Bye.